welcome to our ALM virtual seminar series. I'm Judy Larson, part of the team that puts these on. And I just have a couple things about the technology here. If everybody can just use the mute function to prevent any interruptions during the session. But if you do have questions, you can use either the hand feature, I think it recognizes your hand, or the emojis. You can also drop something in the chat, and we would like to facilitate interactivity. So feel free to ask questions, and we can always bring them to the speaker later, or if it's in the right moment, then we can potentially address those as well. But otherwise, just to prevent interruptions, try to keep on mute unless you're speaking. Great. So we are going to go on to the formal welcome.
It falls to me as the current ALM chair to say a warm welcome tonight or this morning or whatever time it is in your part of the world to the first of our ALM seminar series for 2024-25. So we're delighted to have David with us. David, I have known, I think, since my first ALM conference. And I've always known him as the warm, friendly person who guides everyone who's new and makes them feel at ease. But David has a wealth of knowledge as well. He's got an amazing experience and knowledge of maths education for adults. And we're going to benefit from that this evening. So, David, thank you very much for being with us. We are here for 2 sessions. Hope you can join us for the second session as well in a few weeks' time. But for now, it's over to David, and we look forward to hearing what you've got to share with us.
Okay, thank you. Hello, good evening or morning or whatever to everybody. As you can see, what was put up on the screen now was 5 items that come from history of mathematics, particularly looking at history of numerals and in some ways bits of arithmetic. What I'm going to do is go through is they're kind of a little bit at random, but they represent key events. Look at actually 14 events associated with this, and then there's a little sort of activity to play around with at the end, and then to go into hopefully a bit of time for some further discussion. So I think we can start, Judy. Okay.
Sounds good. And just by the way, everyone, the meeting is recorded. We do have an ALM YouTube channel. If you feel uncomfortable with that, you can just have your face blank or all, it's your choice, but it is being recorded so that we can share it. So thank you for that. All right. Yeah. Would you like to go on?
Yes. So, well, what I was saying is this is introducing a set of events which I'll take through chronologically. And there is a second one which will look at other parts of mathematics and then apply it a lot more to teaching adult numeracy. If we move on to the sort of first event is to look at these, not a form of presenting numbers that click through, Judy, please.
There's someone who needs to mute yeah, thank you. Sorry. If one of the other co-facilitators could pay attention to the muting, that would be great because I'm doing the slides. Thanks. Okay, go on.
Okay, thanks. So we're starting here with these strings that were part of the Inca civilization. And what this certainly, it gives an illustration of, that I give dates of these things, but there's a new discovery. Until quite recently, this was 3,000 years earlier. We thought it was about the time of around 500 years ago. In the last couple of years, there appears to have been some evidence that they are far, far older. Can move on, Judy. And this is what the Kipu looked like. The diagram on the right giving you some idea of how a number was displayed. They kept records, particularly very good sort of accounts of everything on these Kipu, the knotted strings. And it's one of the many forms that different civilizations have chosen to represent numbers, and to think about numbers in a different way. To move on. So counting in 60s like time is probably what really made me think that this was so important to know all along. Click through. And again. So if you think about how you talk about time, you've got 60 seconds in a minute, 60 minutes in an hour. You're using a base 60. And this was the base used by the Babylonian, sometimes now called Mesopotamian culture, where the base for measurement was using 60s. And the whole numeral system was based around 60s. Move on. And the system, their numbers look like this. It's based upon, if you look at the number, the symbol for 1 and for 10, they're all based on those two symbols collected together multiple times to produce 5 or 50 or whatever. You'll note that it goes up to 59, and if you imagine this is counting minutes, when you come to 60, you don't have 60, you use 1 again. And so you would repeat after you get to that 59 in the next position, you would use 1, which moved on in a place value system to meaning 60. And again, in a third position, it'd actually be 3,600, 60s. So, and these were in place for quite a long time, but around 4,000 years ago. Not similar sort of time is the hieroglyphic numerals, which were one of many forms that happened in Egyptian culture. As I say, the dates could be argued. Quite a lot of this period of what you're looking at and what remains has been particularly taken. But the Egyptians had a picture system, move on, which had different symbols taken from the culture, from religious background and many others, that were just for the different powers of 10. And as the example below shows you, or you had a symbol for 100, and if you had 200 or 300, you used 2 or 3 of those symbols. These very much are ways of noting numbers. How calculations were performed was very often in a different form, which we'll look at, is that you had normally some form of counting board, because these sorts of numbers you couldn't operate on like we do with the system. We'll look at that. That comes in later. So these are a way of recording numbers, and the mathematics in a way behind them changes as we move through, but these are just simply recording by counting up how many each of power of 10 you've got. Okay, move on. Moving to a different part of the world, because this is happening across the world, and the beauty for me of treating the history of mathematics as a cultural history is that it is worldwide. No one place dominates, it moves around, and there's exchange, which is, each bit of it can lead to a considerable amount of investigation. So here, this was a set of numbers that was considered about that date. If you look under the little picture, you'll see sets of strokes, which is why they sometimes actually used real rods. And there were two systems. If you see, there's an upper system which you can think of as vertical, if you look at one, and below that there's a horizontal system. And what they did, as you can see from the little diagram, these were used to actually calculate on a counting board. And to save confusion, the vertical ones were used for units and hundreds, as you can see in 105, and in between, so then and continued on, but powers of 10, and the horizontal ones were used for tens and thousands. Partly it's just assumed as a technique just to save confusion, given they're sitting around and you're moving these rods around. I haven't added into it here, but in fact, some of the time and some of the systems in use, they actually used black and red rods to distinguish between positive and negative numbers. But these again was a system of actually doing an accounting process of using the rods that came to look like the numbers, but also used them on a board to aid with calculation. Okay. Right. We now move into the move on. We now move into the classical Greek period, which obviously people mostly know. Mathematics is always associated with geometry. In the number system, we're sort of around 300 BC, which is around the same time as Euclid, that they had this system of using their alphabet. I'd like to move on for their numbers. And what I've given down the side to help think about it is using our alphabet, the Roman alphabet, of how it was used. But you're in the main picture there is given the Greek letters, and as you say, it's almost as really a simple code of the first 9 letters being 1 to 9, the second 9 letters doing 10 to 90, and then moving on to 100 to 900. This was also the same exactly the same structure, using the alphabet under that way, of ancient Hebrew as well. So it was so for that period that this was used. The alphabet was used to record your numbers, and so it has no real position, obviously has no zero. You simply were recording numbers by your letters. Beyond the hundreds into thousands, you went back to the same letters for one with a small mark to make sure that it's gone into higher numbers, into 1,000s and beyond. So it's a system that in a way is, compared to the mathematics they're famous for, of being like a sort of a simple sort of code that again you would need to use some sort of calculating board to do your calculations on, because you can't manipulate a system of this nature. So move, and then perhaps the system of numerals that besides the ones that commonly used is the system of Roman numerals. And I suppose what's remarkable, about them is the length of time that they were actually in operation. That kind of settled around about this period of 100 BCE, but continued certainly in Europe to be used well into the Middle Ages. We move on. And reminding people what they are, of using a set of letters of 1 for 1, 5, 10, 50, 100, 500 and 1,000. What I've illustrated here was that one of the variations that happened over the periods was this use of how you presented 4 and 9, in that there is this way that you could either be shown simply as the 5 plus the 4, but there's also the method that was actually using a subtraction of being an I before X, 1 before 10, or the same as in case of 40 being 10 before 50, rather than using 4, which is sometimes confusing to read quickly, perhaps. But at different periods, that was different parts of that was a variation that happened within the Roman numerals, and they were in use probably for quite a long period, maybe nearly 1,000 years. Again, a system of recording, numbers, and as I say, civilizations producing these throughout time and in all sorts of places. We'll move on to the system that really is vital to what we have now got. Again, I've put a query on here of the 0 as a placeholder. This occurred in some other systems now and again. The important part is that it was in India, that the development of the 0 had this major shift of changing from being sitting in a place of a missing number, to actually having been considered a number itself. And this is explained. We move on. This is explained in this document by the Indian mathematician Brahmagupta. There's again an illustration in this of there sometimes being many arguments about actually when something's happened. In this document in the upper part of the picture of a text that shows a spot basically holding the position of a 0, but even using sort of scientific dating has produced enormous confusion and dispute, of some difference of maybe 500 years of when this might have actually happened. But certainly filling a space where a 0 is to use was a much earlier use than when it started to be considered as a number, as we use in our currently understood counting system that we have of enabling a full place value system to be used. And until this time, it really didn't exist anywhere until about that period of around like 600. Okay. Just as a little offshoot that I thought I'd pick up here, move on, of another way of showing numbers. This was by the Venerable Bede, a monk from the northeast of England, around the year 700, and the system looked a bit like this. We move on. And it's using just the hands and, in a way, body parts to symbolize certain numbers. I mean, this is into a form where you're not using any form of writing at all. And there's other cultures that sometimes use certainly other numbers, certainly counting up to 20, but was a system of using a hand and to position and to represent numbers. As was used, I think sometimes there was a period when it was used for betting of certain odds. So again, there's the wealth of culture just looking at how people use numbers and the ways that it could be done. I think is always important to think about when people are maybe a little troubled by the signs and calculations and methods that we use, that there's been many approaches to this. Okay. So there's not a moving on into Africa. There's not many examples have been found, more be coming through. That this is an example that goes back 1,000 odd years, and is one of the things that another aspect of looking at numbers and counting systems is thinking about the words that are used. This one I pick out because it's got a particularly complicated system around using a base 20. It's not easy to see, but if you look for where the tens are, that, for example, on the right hand side, where you've got 50, which is, I can't remember, a dota, where you've got it expressed as 3 times 20 minus 10, and then for 55 of 3 times 20 minus 5. It's sometimes the number words, although they just become known when you're counting them just as the numbers, but that the number words, or having words particularly for numbers, can be quite important, holds a whole history of the numbers that were used. In English, I've always used the example, for example, is that we have the word dozen for 12 and gross for 144, 12 12s, because there's a history within in the culture of having a base 12, which one time was used for measurement and for money, and that the words that words are carried in the language that are a historical remnant of some of the counting and use of numbers that culture had. If we move on. So now we can make connections with what we're using in our everyday work and lives. That the number system that we have and use now in Western countries and most of the world came to Europe very gradually, slowly. It came from that invention of the zero, discovery of the zero in India, and slowly moved across the world particularly through the Arab mathematicians, and which is why it still carries the name of a Hindu-Arabic system. And the first time it was, although it existed in other parts in Europe, it was first probably distributed by this book, published around 1200, Liber Abaci, by Fibonacci, the same Fibonacci who you may know as the system. That this is a page, and yes, and as you can see that there's a small table there of where the numbers began to be listed, that the numbers that are commonly used nowadays first became part of into the European use of numbers this being particularly taken up first around the merchants in Venice and other parts of Italy. And there's an illustration here, move on. This was a period, a few hundred years later, but it took time for people to get used to it. That this was an illustration that suggested a way of calculating in the two different ways. As I said before, things like Europe, of course, was probably still using, most of Europe still using Roman numerals. And to calculate with them, you use something like, it wasn't in an abacus, but it was a counting board where you moved things up and down the lines with actual counters and recorded your answers, probably in Roman numerals. But other cultures would have used something similar, like the abacus was also invented to do that. Whereas you've got the character on the left is beginning to use and set out the numbers that we now use and using them as a form of system of calculating. And this was still being discussed as which is the best to do, let's say something like 300 years after that publication had begun to bring the numbers in. It was a very, very, very slow acceptance of using these numbers that were not completely trusted at all. And especially the use of zero, which could make numbers so much bigger just by writing that symbol for zero. So all of that work then, that we've seen, so that begins to be accepted, but takes a long time to do it. Like to move on. As an example of various methods of setting out numbers, this was one that, when I was teaching, began to be reused as an idea, but in fact went back to the 15th century, published in a book called the Treviso Arithmetica, and we'll have a brief look at it. And is a way of setting out a multiplication. This being a multiplication of 293 times 276. And what is happening is you're beginning, if you bottom right on the left hand one, beginning in the bottom right hand corner of doing 4 times 4, and you're writing the answer of 16 across that diagonal in the bottom right hand square. And you then proceed to do each of the numbers in each of the other numbers, so that you then you've got the 4 times 3 giving 12, and the 4 times 9 giving 36, and then the other lines, and then in getting your answers you add up on the diagonal. So the bottom right, you've just got the 6, and then in the next diagonal you have 4, 1 and 2, and in the next diagonal you have 2, 0, 3, 1 and 6, and you have to carry into the next diagonal, and then you read your answer around the outside. The other one does it with the number reversed, but I haven't gone into what the advantages of doing that. Yes, somebody might know, but it was a way of a different form of a long multiplication, way of being set out. I think just showing that these methods developed, and this was a late 15th century method that was being popularized in that time. Then we've got moving on to also think about how our system that we use, that things just didn't exist, and that we had the equal sign invented by Robert Record in his book The Whetstone of Wit, which is actually a book about algebra. 1557, we sort of moving into a period pretty contemporary with Shakespeare. And this is in the book where he explains about having the equal sign, and given it's quite hard to read, the transliteration is there following from the and, which is on the third, just at the end of the third row down of the original writing. And so, and to avoid the tedious repetition of these words is equal to, I will set, as I do often in work, use a pair of parallels or Gamow lines of one length thus. And he's got that very long equals that he's written, because no two things can be more equal. And if you're bothering about the sum, you notice the top of the original has the word equation in it. And this, what is written down there, is in fact effectively of what we would write now as 14x plus 15 equals 71. The Z looking sign is where we've now put X. The other signs suggest they're just numbers. But this was his first production, an invention of a sign for equals, rather than putting things in words. So I think it's that an invention of a simple sign like that, is there in the history of the numbers. Okay. So touching on what we now are so full of as machines for doing everything, was around the time a number of these were being invented. So Blaise Pascal, as I say, who is generally the history of mathematics known particularly for his work around probability, also produced a working calculator with cogs, named after him as a Pascaline. Copies of this are in a museum in central France, where he lived, so it's the start of mechanical calculators, using a series of cogs in that, and then dials to show the results of what you're doing. And move on. And our final one for today's talk is of binary numbers, which, given their association with computing, I think is sometimes a surprise that they go back to 17th century, published early 18th by Gottfried Leibniz, who's also much better known in other mathematics of being one of the inventors of the calculus. But in this, he introduces the use of the binary system of using just the 1 and 0 to express all numbers, a base 2 counting system linking to the various bases that we have seen throughout this talk. And that's our quick run through of what I wanted to present to you today. What wanted you to have a look at was to have an experience of looking a little closer at some of the systems that I've introduced. And so, I think Judy, do you want to explain what you're providing people with? So we got
Sure.
an
I've put
activity here for you to look at, and there's another document that will provide the reminder of the symbols that are used. And you might like to, we are suggesting that you spend a little time in groups, and work with these to have a little idea, to have a little bit more familiarity and with what I've talked about, but also to have a little feel for those other numeral systems. And before we have some discussion about it or questions.
Should we check in and see if anyone has any questions about what you